Okay, you're asked some questions about this function right here. It's called a rational function, x cubed over the quantity x squared minus 3. As far as graphing that rational function, here's some guidelines that you might have learned in pre-calculus before you learned how to find derivatives. So you might want to pause the video and take some notes here. But we're just going to do the calculus part. There are some problems with the format of the first derivative. First of all, the numerator, x to the fourth minus 9x squared, should be in parentheses since this forward slash was used to divide the numerator from the denominator. And this exponent should have been a 2, x squared minus 3, the quantity squared, not cubed. Okay, so the domain, really, we want to know when does the denominator equal 0 for this function, because that's where the function is not defined, and that'll happen when x equals plus or minus the square root of 3. So here's one way to specify the domain using set builder notation. Set of all x's such that x is an element of the real numbers, x does not equal negative square root of 3 or square root of 3. And that's the same place we have the vertical asymptotes. So that's one of the first things you want to do when you sketch a graph of a rational function, is sketch in the vertical asymptotes. Since the numerator is greater than the degree of the denominator, there are no horizontal asymptotes. But since the degree is 1 more than the degree of the denominator, there is actually what's called a slant asymptote, which you can figure out by dividing x squared minus 3 into x cubed, rewriting the function this way. And this term, as x approaches infinity or negative infinity, approaches 0. So as x gets bigger and bigger, the y values approach this value, the line y equals x. That's this oblique or slant asymptote right here. Okay, so to find the critical numbers, we want to know when does the first derivative equal 0, and that will happen when the numerator equals 0. So x to the fourth minus 9x squared equals 0. Those are your critical numbers right there. You could include negative square root of 3 and positive square root of 3 as critical numbers, but they're not in the domain of the original function. But if you want to apply the first derivative test, put all those critical numbers on a number line, and I like to put little x's here where the vertical asymptotes occur. That helps picture how the graph is going to be divided into these 3 subintervals. And then you want to find f prime of a number to the left of negative 3. So you put maybe negative 4 into the first derivative. You determine it's positive. So the original function is increasing to the left of negative 3, and so on. Between negative 3 and negative square root of 3, like maybe negative 2, you find out negative, so decreasing, and so on. Okay, and so you can see to the left of negative 3, the function is increasing. To the right of negative 3, but before we get to the vertical asymptote, the function's decreasing. So this point right here, where the tangent line had a slope of 0, first derivative equals 0, is a relative maximum. And you have to plug negative 3 into the original function to find out the corresponding y value. Find local max, local min. So that's what this is, a relative or local maximum. And the same over here, the function went from decreasing to increasing at 3. So there's a relative minimum there at 3. For the second derivative, which is going to allow us to do the test for concavity, we want to know when does it equal 0. Well, the numerator only equals 0 when x equals 0. So we might apply the same technique here, put 0 on the number line along with the 2 places where we have vertical asymptotes. To the left of negative square root of 3, the function, the second derivative is negative, so the original function is concave downward. And that's this portion of the curve right here. Between negative square root of 3 and 0, perhaps a test number -1, we find out that the second derivative is positive, so I think smiley face, concave up. And to the right of 0, to the left of the square root of 3, it's concave down, so there is a point of inflection here. The curve has tangent lines below the curve and then above the curve. And finally, to the right of 3, concave up. There you go. Hope that helped. If you have any questions, post a comment.